Good afternoon, students. So let us continue from where we left. So this question I was explaining in class as well. In the adjoining figure, ABCD is a square of side 21 centimeter. AC and BD are two diagonals of this square. Two semicircles are drawn with AD and BC as diameters. Find the area of the shaded region. So this is the diagram that I have with me. Okay. So ABCD is a square and AC and BD are two diagonals, and there are two semicircles at the end of this diagram. Okay, so we are supposed to calculate the area of the shaded region. So I'll start by saying we have two semicircles at the end. Its area equals to 2 into area of the semicircle. So 2 into pi r square, so that should give me 22 by 7 into 10.5 square. How I got 10.5 square is, question has told us that the side whose length is 21 centimeter of the square will also be the diameter of this semicircle, and area, this one radius is nothing but 21 divided by 2, that is 10.5. So that's how I got 10.5. So it will become 346.50 centimeters square. Yes, and square ABCD, if you see here, can I say that if I add up all these four triangles, I'll get the area of this square? That's what I'm writing here. Area of triangle AOD plus area of triangle AOB plus area of triangle COD plus area of triangle COB equals to area of square. Okay, and I have already told you area of all the triangles will be equal. So let it be x. Okay, I'm assuming it to be x. So can I say, because all of them are equal, can I say x plus x plus x equals 21 square? Yes, I can say. So x plus x, it happens to be 4x equals to 441. So therefore x equals to 441 divided by 4, which happens to be 110.25 centimeters square. Yes, so therefore area of shaded region inside the square is, yeah, because there are two triangles, so I'm going to calculate it 110.25 plus 110.25, which happens to be 220.50 centimeters square. So therefore area of the shaded region equals to the area of the semicircle, that was 346.50, plus area of the two triangles, that is 220.50, which when add will become 567 square centimeter. Yes, so let's go to the next problem that I have, which says in the figure given below, ABCD is a square of side 14 centimeter and APD and BPC are semicircles. Find the area of the shaded region. So area of the square equals to 14 square, that is 196 square centimeter. Okay, and in this case area of two semicircles will be 2 into pi r square divided by 2. If you see here, the 14 centimeter, that is the side of the square, will also be the diameter of the semicircle, and radius is nothing but half of the diameter, that is 7. So that's why I'm using the value out here as 7. So that happens to be 154 square centimeter. So area of the shaded region will be equal to area of the square minus area of the semicircle. Yes, so this will be 196 minus 154. Here remember, I'm calculating the area of two semicircles, that's why I'm using 2 into pi r square by 2. Yes, so 196 minus 154 will become 42 square centimeter. Yes, so next question that I have is, in the figure given below, ABCD is a square of side 14 centimeter. Find the area of the shaded region. So I have a diagram something like this. All of them, remember, all of them are circles with equal shape and sides. All of them are identical. So can I say if the side length of the side is 14 centimeter, then the diameter of the circle will be 7 centimeter. Can I say that? Because two diameters is adding up to 14 centimeter. So diameter of each circle will be 14 centimeter. So I'm writing diameter of each circle equals to 14 by 2, that is 7 centimeter. And radius of each circle will be 7 by 2, that is 3.5 centimeter. So area of 4 circles equals to 4 into pi r square, that is 4 into 22 by 7 into 3.5 into 3.5, which turns out to be 154 centimeters square. And area of square equals to 14 square, that is 196. So area of shaded region will become 196 minus 154, that is 42 centimeters square. Okay, so let's go to the next problem. In the figure given below, the diameter of the semicircle is equal to 14 centimeter. Calculate the area of the shaded region. Okay, so diameter of the semicircle is 14 centimeter. If you see properly, this will also be the length of the rectangle, that is 14 centimeter. Okay, CD here of this 14 centimeter and AB will also be 14 centimeter. Also, one thing, if you notice properly, there are two quadrants of a circle, that is ACE and BED. Yes, and the radius of them will be half of the diameter of the circle, that is 14 centimeter. So it will become 14 by 2, that is 7 centimeter. Yes, and now the rectangle's length has become 14 and breadth has become 7 centimeter because AC will be 7 centimeter. So area of the semicircle equals to pi r square by 2. So 22 by 7 into half into 7 into 7. So that will become 77 centimeters square. Here AC equals to half into 14, that is 7 centimeter. Yes. So then area of rectangle ABCD equals to 14 into 7, which happens to be 98 centimeters square. I hope you are clear how I got 14 and 7. So area of two quadrant of a circle equals to pi r square by 4 plus pi r square by 4, which happens to be pi r square by 2. So 22 by 7 into 2 into 7 into 7, which will give me 77 square centimeter. Yes. Now area of the shaded region will be nothing but area of the semicircle plus area of rectangle minus area of the two quadrant of a circle. If you didn't get the logic, kindly rewind the video. You'll be able to notice it properly. So that happens to be 77 plus 98 minus 77, that is 98 square centimeter. Okay. So the next question that I have is, find the area and perimeter of the shaded region in the figure given below. Area of the bigger semicircle, see here. So it is given 28 centimeters the length. So diameter radius will be 14 centimeter, and the radius and the diameter of the smaller circle will be 14 centimeter. Because diameter is 14 centimeter, radius will become 7 centimeter. Yes, so let us start. So area of the bigger circle equals to pi r square by 2. Remember, we are speaking about semicircle, so it will become pi r square by 2, which turns out to be pi into 14 by 2 into 14. Yes, so 22 by 7 into 14 by 2 into 14, this will give me 308 square centimeter. In case of smaller semicircle, the radius will be 7 centimeter. So area of the semicircle, I'll use the same formula. I'll get 77 square centimeter. So area of the shaded region equals to 308 minus 77 equals to 231 square centimeter. So this is clear. So now we are supposed to find the perimeter as well. If you see, perimeter will be the circumference of the bigger circle. That means without taking the diameter, only the curved length plus the curved length of the smaller circle and also the radius of the bigger circle, that is 14 centimeter. I hope you are clear with the perimeter part. So I'm just putting the value. I'm writing perimeter of the shaded region is circumference of the bigger circle plus circumference of the smaller circle plus radius of the bigger circle. Remember, there's a slight difference between perimeter and circumference. In case of perimeter, you consider even the radius part, but in case of circumference, we consider only the curved path, okay, of a circle. I hope this is clear. So remember, circumference of a semicircle is given as pi into 14. So pi r plus 14. So this is how I am getting 80 centimeter. Yes, I hope this is clear. So the next question that I have is, in the figure given below, area of triangle ABC equals to 35 centimeters square. Find the area of the shaded region. This is also very easy. So we are given 35 centimeter. So if you notice, this is a right angle triangle. Sorry, not right angle triangle, but a triangle whose height has been given as 5 centimeter and area also is given. Using that, I'll find the base AB. That base AB will also become the diameter of the semicircle whose area we are trying to find. Okay. So area of triangle ABC equals to 35 centimeters square. We know area of triangle ABC is half into base into height equals to 35. So this will become half into AB into CD equals 35. So using this relation, I'll find AB equals to 14 centimeter. So this AB, if you see, is also the diameter of the semicircle in question. So I'll write radius of the semicircle equals to AB by 2, that is 14 by 2, that is 7 centimeter. So then area of the semicircle equals to pi r square by 2. So this will turn out to be 77 centimeters square. So therefore, area of the shaded region equals to area of the semicircle minus area of the triangle. That is 77 minus 35 equals to 42 centimeters square. Yes. So the next question that I have is, in the figure given below, OAB is a quadrant of a circle. The radius OA equals to 3.5 centimeter and OD equals to 2 centimeter. Calculate the area of the shaded portion. Okay, so we are given this much data. OA equals to 3.5 centimeter, which also becomes the radius of this quadrant of a circle. Also, OD equals to 2 centimeter. Yes, so I'm going to calculate the area of the triangle AOD equals to half into base into height. So this will turn out to be 3.5 centimeters square. Again, area of the quadrant equals to pi r square by 4. So 22 by 7 into 4 into 3.5 into 3.5, 9.625. So area of the shaded portion equals to area of the quadrant minus area of the triangle. So equals to 9.625 minus 3.5 equals to 6.125 centimeters square. I hope you are clear with this. So let's take the last problem. A student takes a rectangular piece of paper. Okay, for today we'll do this much. Okay, I'll meet you in the next class.